but that's, you're right though, if you wanted to push the energy one way, then you just put the reflective barrier behind it.
Just have to be careful where you put your pictures.
That's true. There was lots of places where we couldn't put pipe in the wall.
So these are basically hot water radiant systems that you're talking about?
Yeah, well, they're warm water, like a radiation heating system. I don't know that we've ever built one that was over 40 C. 105 Fahrenheit. You can, there's some configuration you can put together, obviously, that is higher than that. But, you know, like if we go back to boilers, and of course there's numerous kinds of boilers, and the boilers that we were accustomed to was atmospheric boilers. It worked on atmospheric air, and you got a burner assembly, and it heats water, but it has to be above 140 degrees because it's not a condensing boiler. So there's all kinds of systems that were built where they're hooked direct to a minimum temperature 140 degree boiler. So there you are pumping out 140 degree water, and when the temperature is met, it shuts off. Well, there's two things happen. One is the floor gets so hot that you can't walk on it. And then the second thing that happens is when you shut it off, it doesn't cool uniformly as well. So, and the other interesting thing is that when it comes to boilers, most people don't understand boilers. They don't know the differences in them. I mean, you got a low mass boiler, which is a stainless steel or aluminum heat exchanger, and it has instant heat the minute it fires. And then you'll have an atmospheric boiler, which has got a huge amount of water in it and cast iron, so it has a lot of thermal storage. And then the next boiler you got that we're into now, of course, is condensing boilers. Now, flue gas has a huge amount of water in it. And when you condense it, every pound of water you condense out of the flue gas, you add 1,000 BTUs to the output of the boiler. And condensing boilers now commonly are in the 96% range. And of course, and not only that, but the lower the water temperature going back to the boiler, the better. If you look at an atmospheric boiler, you can't have water going back to it below 140 degrees. Otherwise it rusts out. So there's a fair bit to know about, about the process.
Where we're building, we don't have any gas, and we were thinking about doing a masonry heater in the middle with in an ICF house.
Mm-hmm.
And have you ever done an installation where you use a hydronic floor system heated by a masonry oven? Like, is that possible, or is it not necessary?
Oh well, it's certainly possible, because one of the first time I ever saw radiant floor heating was in Helsinki. And that's exactly the way it was set up. It had a huge thermal mass system, like a fireplace, right in the center of the house. And that everything went to storage, and everything went to the heating system. But there's several other ways to go too. One of the things we're doing now is we're taking solar energy and supplementing what's called geothermal. It's not a true description, but ground loops. And you dump surplus energy from the solar system into the ground. Now, typically, a heat pump with an EWT entering water temperature of 40 degrees will have a COP, coefficient of performance, which means for every kilowatt of energy, and you get so many kilowatts out, would have a COP of 4. So you're multiplying the energy input 4 times. That's what your output is. You go to a solar system where you're rejecting surplus heat into the ground, you can get COPs up to 6 and 7. The first solar-assisted ground loop we ever did was just out of Saskatoon here. That was about 18 years ago.
I don't know that one.
Louis Pichet is the guy's name. I don't even know if he's around anymore, but that's how long ago it was. But anyway, and we're doing a system right now down in Montana that is it got a solar reject. One of the problems with solar energy, I know we're getting off the topic here, but solar energy, there's an unlimited amount of solar energy. I was at a conference here not very long ago where they said there's enough solar energy in the prairie region of North America to supply the world with power. Now they didn't designate if that included industrial power, but what they did say, for sure it meant all of humankind's consumption of power could be produced from solar energy from the prairie region of North America. If we had spent as much money in researching solar energy as we did nuclear, I think we would be probably at the 50 or 60% range of solar energy. But solar energy, you have such an abundance of it in the summertime, and you have long days, all kinds of energy, and then in the wintertime, it isn't that you have any less energy per square foot available, because temperature doesn't make any difference to solar energy. But you got a short day, 4 to 5 hour day. So you have to produce, you know, the energy in a 4 or 5 hour period. And that's one of the reasons. The secret of success in solar energy is storage. If we can put enough storage into the ground, we could create a zero energy house quite easily. Well, it takes the energy to run the mechanical equipment, but in terms of the total source of energy, it's certainly available from solar alone.
What are your thoughts on radiant cooling systems?
Well, that's primarily the only cooling there is in most systems in Europe. I guess they do have some forced air, but when we were over there looking at systems over there, if you keep a floor at 20 C, the house will never be too hot. One of the critical things you run into is solar gain. And when you have a thermal mass floor, it used to be there was a control built where it timed the heat gain and the drop, the loss, and all the rest of it. And of course, this thermostatic system shut the flow off. And then at 4 o'clock in the afternoon or whatever, it turned it back on again. And we got hooked into that on a couple of systems, and then we come to find out the worst thing you could do is shut the flow off, because then it doesn't take it away. If you leave it circulating, the heat gets dispersed off to the colder floors. Houses, I don't know how many, but the last number of houses that we've done, there's always the question of air conditioning comes up. And so I say, don't put any air conditioning in until you've lived in it through a summer, but leave the radiant floor circulating, and not one of them put in air conditioning. There is just endless things that we can do, and we need to do, and we should do. We just did a system in Moose Jaw. Air conditioning, part of the house was on forced air. Air conditioning, first of all, it should never be delivered from a floor system. It should come from above, because cold air falls. But anyway, we put this system in. He wanted air conditioning. So we condense on water. We use a 100-gallon storage tank, and that creates the condensation for the cooling, and that's the preheat for domestic water. And this is commonly done in Europe. It isn't.
Maybe, I don't know what Vic means, instead of having an air conditioner outside with a fan blowing the heat off into the air,
yeah,
it condenses it, it has a water jacket around it and takes that heat that the air conditioner is trying to get rid of, puts it in a 100-gallon tank, so just in case that wasn't clear.
But anyway, this particular customer in Moose Jaw said he didn't think it cost him 5 cents for domestic water. But we've always done this, you know, like district heating systems. My God, the waste heat that we've got, and we associate that with district heating systems, we could eliminate 70% of the energy demand for heating systems.
I have a question. We're looking at putting in, well, we're doing probably a masonry heater, but for backup heat, we're looking at radiant in-floor heat. But we only have electricity. So what would be, is there any reason to put in hydronics rather than direct ceiling panel radiant heaters?
Well, ceiling panels radiant heated typically are higher temperature, but if you use reflective backgrounds in them, you can run them at very low temperature. But you said that you're going to put in radiant heating as a backup.
Well, we're using a masonry heater, so
Okay.
you need
Yeah.
insurance, and everybody else wants to see that you've got something else that when that's not functioning. Also, that's on our main floor, and for bottom floor, we'll probably need some supplementary heat then.
Well, radiant floor heating should be used for every form of heating. I mean, it is the most efficient form of heating there is.
Well,
I may be biased, but I think I have good reason to be biased. I mean, you can use any source of energy for radiant floor heating. It doesn't matter where it comes from, a hot bellied stove, if you put the jackets, heating coils in it, or it doesn't matter where it comes from. Building a good thermal barrier, a good thermal envelope, that's the key to success there. And you could have a little heat pump. We got a 3,000 square foot house here in the Saskatoon area that has a 5-ton heat pump in it. The reason it has a 5-ton heat pump is because heat pump installers sell 4, 5, and 6-ton heat pumps. That's all they sell. But this 3,000 square foot house would run on a 1-ton heat pump. And the 1-ton heat pump, you know, isn't all that expensive, and it uses electrical energy, but you know, all